Welcome to another One More Epoch Live. Today it's a special one. Today it's remote ML apps with cellular IoT, and it's going to be a really cool show talking about how ML and IoT come together. And it's going to be with two of our special guests from Blues Wireless. We're going to have a chance to speak to them, ask them questions, hear all about Blues Wireless and how IoT connectivity works. And also, we're going to give out a discount code, right, Artie?
Yeah, so first and foremost, let us bring on our guest today. We have Brandon Satrom, the VP of Developer Experience from Blues Wireless, and Rob Lauer, Developer Relations Lead at Blues Wireless. So welcome, guys. Thanks for joining the show. We are going to be kicking things off, though, to celebrate the success of Blues Wireless and having them on with a 20% off coupon code for one of their 2 starter kits. And we're going to share that right now. So by going to the bit.ly/blues-omel, you're going to be able to then choose one of the 2 wireless kits where you're going to be able to save 20%. So thanks, guys, for doing that. And all of you definitely should check that out.
Guys, you want to tell us a little bit more about what we're giving out here? What is the kit? And then we'll dive into what Blues Wireless is. But let's tell people what the kit is about.
Yeah, absolutely. So the discount code is good for any one of our developer kits. So there's 2 varieties. There is a feather-based kit that includes an ESP32 and our core cellular product, the Notecard, and a Raspberry Pi hat equivalent as well that has the nice little hat top with the 40-pin header connector and the Notecard in there as well. So whether you're doing single board computer development or working on a microcontroller, we've got a kit that you can get started with.
We've got you covered. Awesome.
Right.
Awesome, guys. Well, I want to give both of you a chance to introduce yourselves and tell us who you are, how you got to this point, how you got to this amazing startup. So, Rob, do you want to start?
Sure. Yeah. So again, hi everyone. Rob Lauer, Developer Relations Lead here at Blues Wireless. My journey, I don't know if it's a typical journey, but I started as a web and mobile developer in my early years, and serendipitously ran into Brandon and his squad who are working at a .NET UI control and JavaScript library company, Telerik, who some of you may be familiar with, and got into DevRel from after a long stint in engineering, got into product management for a while, always considered myself a front-end, full-stack engineer for many, many years. And then Brandon joined this startup about a little more than a year ago, I guess now, and brought me along for the ride. And it has been honestly a fantastic journey. Great company, great tech. Yeah, super happy to be here.
Brandon, a little bit about you.
Yeah. So Brandon Satrom, I'm the VP of Developer Experience at Blues, and I similarly in my 22 years of working in technology, spent a lot of that time working as a front-end engineer, as a web engineer. And about 8-9 years ago, I started dabbling in the side in the IoT space, doing the maker thing, buying every Arduino, Adafruit, SparkFun device that I could get my hands on. And through just some career change opportunities, I had a chance to get into this world professionally. And I joined Particle about 4 years ago and spent some time working with them in that developer community. And then I had an opportunity to speak to Ray Ozzie, the CEO of Blues, and our team, and to just come along and build out their developer experience from scratch and start to think through, helping them get to a place of building what we like to call developer-friendly cellular IoT products. So I've been doing that for about 14 months now, and we're just getting going. It's very exciting.
Awesome. And I'm going to pick your brain in a little bit. I think I'm going to ask you first. I want you to tell us what Blues Wireless does, but after that, I want to dive into you said build out a developer experience from scratch, right? I'm really keen to hear some of the kind of key points of an awesome developer experience. I mean, you've got the experience with Particle as well that also has an amazing developer experience, right? So I'm keen to go into that in a bit, but first, you want to tell us about Blues Wireless?
Yeah, absolutely. So Blues Wireless, as I said, we style ourselves as a developer-friendly IoT company. So we our core product is a device called the Notecard, which is a small cellular IoT modem that you can use with any MCU, any single board computer, really anything that can read and write JSON. You can work with a Notecard, and it is a cellular IoT modem that's baked onto the device, and you communicate with it using JSON requests and responses. So it's very nice for folks that come from a web background, or even people that, if you don't, I mean, you're not writing AT commands to turn on the modem or to send data. You're literally just sending JSON objects with strings of data. So you read from your sensors, you send that through the Notecard, and because it's a cellular IoT device, it's actually completely secure, communicates over our partner networks and VPN into our cloud, and the cloud service is NodeHub. NodeHub is a very simple cloud service that's really designed to allow you to ingest your data and then send it out to your ultimate cloud application. We really exist to try to be that very thin piece of middleware between your sensors and your host applications and your ultimate command centers, dashboards, wherever your cloud application of record is on the other side. We're trying to make it very quick and easy for anyone to connect any sensor to any cloud application. And so that's really the genesis of a lot of what we do.
And I love that you already have someone that says, I think that agrees with you completely, right? So you just rewrote the rules on how this stuff should work from 2020, or actually from 1980 to 2020, right?
I love that. That's awesome.
So yeah. Hi, Shot JR. Thank you for joining.
Yeah.
Cool.
I just wanted to add quickly, I think today, what I like to tell people is that today we are very focused on cellular, obviously, but that doesn't mean that's all Blues is ever going to be. And we're also, this is putting my DevRel hat on. We're not here to talk people out of Wi-Fi, Bluetooth, or LoRa either. This is not an either or situation. I think a lot of the solutions that we frame, paint cellular in a light where it's a very reliable, fallback connection for some scenarios as well. And how certainly LoRa and cellular, they don't have to be competitors, in this space, that they can work off of each other in various situations too. So just wanted to make that clear.
And that's kind of why we're brought here today, right? It's the whole complementary stuff. So with machine learning and cellular IoT, it's everything. Everybody works in tandem, and I think that's what's so exciting about this space.
Yeah, absolutely. I mean, I've been doing machine learning work and edge ML work for the past 4 or 5 years now. From the initial, some of the initial demos and conversations that I had with Pete Warden about what was happening on the TensorFlow team. And I, from the beginning, felt like, okay, so this is a place where these two work really well together, ML, IoT. And then when I first caught wind of Edge Impulse and then moved over to Blues, a lot of for me, the easy inspiration was like, these are two technologies that are kind of a match made in heaven. This idea of doing processing at the edge and then leveraging the vast deployability of cellular IoT solutions to be able to actually detect anything, anywhere is really powerful.
And that's something we're going to discuss later on in the show too, just highlighting some of the applications that you guys have both built and just showing that, how could you use Blues Wireless? How could you leverage Edge Impulse and deploy a remote machine learning application? I think that's going to be really fun to, delve deeper into.
Yeah, and you guys have built some really, really cool examples of exactly that, right? And what's really interesting is the traction that you're getting from the community. I mean, it's been impressive to see all the people kind of rebuilding similar things or trying to kind of convert what you've done into something slightly different. It's really cool, actually. It's really inspiring. So yeah, Artie, do you?
Yeah, well, I was just going to say, also in terms of traction, just want to give you guys both a huge congratulations too on your recent closing of the funding round with $22 million Series A. That's super exciting to see you guys growing and accelerating that quickly as well. So, kudos to you guys and the team and Ray.
Thank you.
So, I guess shifting gears quite a bit. Maybe a few weeks ago, I had saw Brandon, you wrote an article about why IoT developers still matter and how within the enterprise, it's still the developer who's driving the ultimate success or failure of an IoT project. And this one really resonated with me. So for those that don't know, my career started back in 2013 with Atmel. It was at the nascent stage of the quote unquote maker movement, where there was so much enthusiasm and passion around what people were building. And I'm starting to see that same sort of resemblance nowadays. with tinyML and the embedded ML space. It's really exciting to see in this kind of projection. But back to what your article was about, was the fact that a lot of times people kind of, categorize developers and makers together. You're a tinkerer and that's it. But a lot of people fail to recognize the fact that that person who is tinkering or developing projects at night is actually a full-time engineer, embedded developer or whatnot during their full-time job. So, that's the end user, and that's who companies are trying to reach. So the fact that, this quote unquote maker movement and people kind of put that stigma, it's not the case. So I think, your article, which I'm going to highlight right now, was just, the epitome of what I've been preaching for years. So
I'm glad it resonated. It's a soapbox topic of mine. And I've been saying a similar thing for years now as well. I think there's this tendency, especially among commercial businesses like ours, that you feel like, all right, so if you treat developers as purely this like, oh, we just want to drive awareness with developers, but the real customer is the enterprise. The real customer is the enterprise. But the reality is that the enterprise is made up of developers. There are still developers that are doing the actual work. They're deploying the solutions, and many of them, we don't live in a world anymore. In my early days in software, that you refer to it as sort of a sales-led growth way of building products, right? So you had your the CTO that would tell the team, you're using Oracle, and it doesn't matter what you think about Oracle, you're using Oracle. And that's not the world we live in anymore. Developers have been deputized with power to make decisions, even in the enterprise, right? They have the ability to sign up for tools with a credit card and pay $10 a month for something, or they have the chance to, as they're tinkering on nights and weekends, and their company comes and says, hey, we need to do this IoT thing. We don't know how to do it. And their developer can raise their hand and say, I do. And I know a great company that I'd like to recommend. Like, there's power in that sort of model. And I think as companies that are looking to serve developers, we should keep that in mind. I mean, that's still the path of helping enterprises solve big problems still starts with enabling the developer to do great things quickly.
And I've always been pitching this myself as well, right? Like when I was a couple of years ago, before the pandemic, being at conferences, I was at one point at the Hackaday SuperConf, and it was funny. I was, it's one of the, in my experience, it's been one of the probably the best conferences I've been to. Actually, it was really fun. A lot of like really intelligent people all in the same room, like doing really cool stuff. And there was this area outside where you had like all this ability to tinker with like all these different devices and things. And it was cool. We were doing all these projects, we were hacking on stuff. And I was sitting beside all these people, and you start talking to them, right? And like, oh, what do you do? What do you do? And this guy that was building beside me, he was building a little. He was actually, it was a shark, an inflatable shark that was like driving around, like floating around, and he had like a little way of like making him move, right? And his day job was at Uber, right? And it's super interesting because you're like, these people, as you said, right? Like these people are at big companies, right? It's just that, as everybody else, they like to have fun as well, right? And they do fun stuff on weekends and whenever, right? On evenings. But I really think that's how creativity, like to spark creativity, you also have to like put yourself out of the kind of performance zone sometimes, right? And you have to like really kind of try new stuff out, explore, right? And that's the maker move.
And that's why we love, both personally and professionally, like we post projects to Hackster because it's the kind of thing that we would be doing anyway, even if it wasn't part of the day job. But we love doing it because we think it resonates with people that are looking, they see that thing, and then and I got a lot of comments on one of my first project here of, I want to be able to do a similar thing. I'd love to do this in my, my house, whatever. But you can also take that and map it into a quote unquote enterprise use case for tank monitoring or remote asset monitoring or so. It's not that hard. It's a very short step from the makery project to the quote unquote real project. And it really starts with giving people the ability to think laterally and get inspired about how to solve problems with these technologies, which is that's what excites me about this.
Yeah, I was just going to use that word.
The community is so important. Sorry, Rob. That's just also why the community is so important, because companies need to learn to leverage the community, use that as like the ideation, as the incubation phase, because you're seeing a lot of applications, a lot of use cases appear that you may otherwise not have known about, or it might, spark some sort of idea for a future product. Things like that, where I think a lot of companies just aren't cognizant of the fact that there's a lot of innovation taking place in that space. And you guys are doing a fantastic job with that.
Yeah, I was just going to say, like, that keyword inspired is big for me, because the projects that we create, that we publish under the Blues Wireless moniker on Hackster, we don't really expect people to want to build out some of the things we're doing from beginning to end, right? Some of the things we do are wildly impractical. I mean, that's a lot of the traditional IoT projects. They're just kind of way far out there. But our hope is that, I mean, ideally, are you using our product eventually? Maybe that'd be great. But our hope is that you find little bits of inspiration somewhere down the line, right? You're finding like, oh, I was trying to learn how to add a 7-segment display to something, and there's a little piece here. Like that's really what we're building these projects for. It's not that everybody wants to build a remote birding solution. Like it's silly, it's dumb. It's.
But talking of which, should we start with you, Rob? And do you want to start chatting about?
Sure.
Which one should we start from, actually? Should we start from the birding one?
We could start with the birding one. That's fine. Yeah. So this is one of the first projects I worked on when I started at Blues Wireless. And, I guess to back to my backstory a little bit, as a front-end developer, mobile developer for many years, when I would encounter a problem, or a friend would convey a problem to me in their life, not a personal problem, but a logistical problem, I'd always be limited. Can I write a web app that'll solve this, or a mobile app that will solve this? And so that really limited me in terms of what kind of real world value I could put out there, right? However, since joining an IoT company, the veil was pulled back. And I realized there are very few problems out there that we can't solve, which is really an amazing thing to be able to say. So case in point, this is totally a pandemic story where, I'm sitting at my back window with my coffee and my robe, looking at the bird feeder one day. And I'm thinking, boy, wouldn't it be cool if I could automate this process? Not in terms of like, I don't want to ever watch birds at the feeder, but wouldn't it be cool if I could identify birds that landed at the bird feeder and maybe send me a text message so I know that there's some, one thing that'd be cool, like here in my backyard, we get 5 or 6 different birds. What if there's a migration coming through and there's a cedar waxwing or something that I only see like once a year? What if I could get a text notification that it's up there and I can run up to the feeder and see it? And so I thought, this light went off in my head that I can actually do this now. Like this is a new thing to me. So the way I approach many projects is the way I approach this one, where I just started mapping out what are the different pieces involved on the hardware and the software and firmware side of things. And I realized that, well, I've got Raspberry Pis sitting around. I have a camera module. I have I knew I would need some kind of sensor to identify when something might be at the feeder. And well, I've got this new company I work with, Blues Wireless, that can actually in near real time notify me that there is some data element to be passed from that solution to the cloud down to me. And what else is involved in the project? Oh, like a battery pack and solar for power, because I wasn't going to run a 100-foot extension cord out in my yard. And I broke these all down into their bare pieces, and I was like, let's see, to use for instance, I use a PIR sensor to activate the camera, just for battery, to be battery or power conscious rather. And well, it was my first time using a PIR sensor, but I just looked online. Oh, there's a Python library for this. And it was like just repeating this process of, okay, I got either I have a library I can use, or there's literal sample code I can copy and paste. So I'm a total fraud here, just so you all know. Like I copy and paste all my code from Stack Overflow and other people's GitHub repos. But no, I was just ended up in this literal like puzzle piecing together this solution, and on the hardware side. And the last kind of component was machine learning aspect, because it's one thing to, well, there's motion detected, take a picture and send it to me. But I knew realistically, in an outdoor setting, it gets windy, it's rainy, everything and anything is going to trigger this sensor. And I would just be polluting my data set. And so this is a classic like edge computing scenario where I want to perform all the inference on the edge because I don't want to send a lot of data, not only just to be, miserly on the data side, but also to waste my time. So in this case, this project, again, I kind of cheated here and I went to TensorFlow Hub and I downloaded a TensorFlow model of literally every bird in existence. At the time, my thought process, it was, hey, I don't want to miss out on a bird. Therefore, this seems like the perfect model for me. Fast forward in time, when I started working on the final deployment, I would, the very first bird that was identified ended up being a red jungle fowl, which is not really, it's a, not really known to be in Wisconsin where I am in the States. So I realized that it was like my first real lesson in machine learning, which was, the inferences that are created are only going to be as good as the model that you're using, right? And so that was a great lesson to learn. It has helped me in every project since then to kind of optimize my model and to limit the scope of what I'm trying to solve here. I can certainly show some code if you want to see it, or a demo unless there's any questions.
Yeah, while you do that, maybe while you bring the code up, I'll just say that you said the right thing. Like any machine learning inference is as good as the model, but actually I would even go a step further and say it's as good as the data that you feed in, right? The model. So it's interesting because it's always about how good is your data in order to make sure that you've got a good model. You have to have really good data, right? So, and to your point, if you've never seen that bird before or you don't expect it, you can't feed it to the network, right? So that's always an interesting problem when you bring stuff, models in real life situations.
Absolutely.
So I'll bring up your code.
Yeah, I don't need to go through this in any kind of detail, but I just really, my point here is to kind of show off that this one Python file, which is, I'm sorry, I'm going to scroll really quickly here, is about 118 lines, right? I mean, that's pretty amazing to me that I could build an end-to-end solution with this amount of code. Really, I mean, and it's, again, it's like, it's all kind of too simple, like too good to be true, really. In terms of, I'm initializing some sensors here, initializing the Raspberry Pi camera, I'm initializing our Notecard. And again, as Brandon mentioned, you have a Notecard, and that is associated with a cloud project on notehub.io. So that's what I'm doing when I'm executing this hub.set API request, is I'm essentially linking those two. Then I'm setting the mode of the cellular connection into periodic mode, which means only connect to the cellular network every X seconds. In this case, happened to be 120 seconds, which is actually probably a little too frequent. The reason we do this, so we have this whole idea of, low power hardware to begin with the Notecard, but it's also power conscious firmware and API. So you can set up a continuous cellular connection, but of course that's going to drain your battery more quickly. So we allow you to customize this to connect. I mean, I could set this periodic mode to connect once a day, once every few days, once a week, and so on. I thought maybe every 2 minutes would be okay for this. And the rest here, I mean, it's all going to be straightforward, and this is all available on my GitHub or via the Hackster projects themselves. But really, all I'm doing here is I'm checking, is there something every 30 seconds, check to see if that IR sensor has detected anything. If so, well, execute this check for bird method, which is it's gonna start the camera. It's gonna give the camera a couple seconds to adjust its light balance, grab a picture, send this picture to the TensorFlow Lite runtime. And I mean, I'm really glossing over a lot of complexity here, but that's just all we're effectively doing, right? And if the probability, my very poorly named prob variable, if it's greater than the inferred percentage result from the TensorFlow Lite runtime, then I'm going to add what we call a note to the note card. This means that a bird was identified. So when this note is added, sorry, I'm going to skip ahead here. We're calling the note.add API, which is really just going to say, here's the bird, and this is all JSON. So everything we do is JSON in, JSON out. Here's the bird, here's the probability, that percentage. And in my case, I was using Twilio on the back end. That's the only cloud integration I was using. And the phone number from Twilio to my personal number. So really, that's all it was. You know, is there motion identified? If so, take a picture, send it to the TensorFlow Lite runtime, process it, and if a match is found, send that to create a note on the note card, which will then every 2 minutes send that up to notehub.io, and notehub.io will route that data to Twilio and send me a text message. Pretty fantastic, you know, in my opinion. I could stop sharing that code.
And you know, it's funny because you had mentioned how this was just kind of an entryway into, you know, this project space. But truth be told, this was really a proof of concept to see how you could leverage hardware to perform remote cellular communication outside of Wi-Fi and the electrical grid. But yeah, so there's a wide range of applications that something like this could actually be deployed. Do you have any sort of examples or things that you would like to see in the future, or, you know, you have seen?
I mean, when I think about this project that I built, since it was the first machine learning project I created, I did overpower it with a Raspberry Pi, to be honest. Like, I think I got kind of down this path of like, how feasible is it really to use a Raspberry Pi in a remote setting? And I created some other content around that. I just, in hindsight, if I ever do a V2, I will definitely scale it down to use a microcontroller because it's amazing. I think I was intimidated by machine learning, and I was like, I don't want the hardware I choose to be a bottleneck for me. Right.
With something like the Pico, would that like, is
exactly.
It, yeah.
That's the first thing that came to mind, because I could still use, I mean, I could effectively use almost all the same code, if not all the same code. Exactly. On a microcontroller. Yeah. So just in terms of like this project, I would love to scale things down a bit.
Yeah, this was one of the, and to your point, this was one of the first projects. So, you know, as I'm manning the social media channels, this one just seemed to be so popular and resonated really well with the community. So everybody tweeting about it, very similar to your, you know, your more recent project. For those that haven't seen it, this machine learning powered speed trap, where you deployed this portable sort of system that was able to identify when a vehicle was driving by. You were able to, you know, calculate the speed through a radar sensor, and then ultimately send that data to the cloud. Not specific vehicles, but more so on a macro to show your municipality, like, hey, people are recklessly driving here. So when I see these applications, I just, you know, my mind starts going that there's just a wide range of things that could be done.
I know. I mean, and it really, the model for this this speed trap project is not that dissimilar to the birding one. I mean, it's the same kind of general concepts that we're dealing with here. And yeah, just to double down on the point you made, and this comment has showed up in multiple places, like there's no PII, there's no personally identifiable information that is gathered in this process. You know, we're using machine learning to identify, is it a car versus is it a bike? Is it a runner going by? Like, that's all we're doing. So yeah.
Because that was the thing. This one might have been more popular than your earlier project, because your first tweet just seemed to go viral. Everybody was talking about it. And all of a sudden the media picked it up. I saw it on like Tom's Hardware. You know, our team internally was discussing it. It was just, you know, it was an awesome use case. And, but the first thing that you saw a lot of people reply was, oh, this is Big Brother watching you, or, you know, you know, stuff like that. But, you know, you weren't identifying people based on license plate. You weren't doing anything like this. This was just, you know, you have a family, people are driving recklessly super fast down a neighborhood street, and you try to, you know, rectify the issue. Machine learning and cellular IoT.
And though there are valid privacy concerns for sure, because it is it would take very little effort to then, you know, gather license plate information, which I don't think is PII, but it's a slippery slope. Yeah.
But one thing that's worth mentioning at this point is actually, you know, to your point, you're not doing that, right? And the beauty of doing the machine learning on the device is exactly that, right? Like, you don't need to do that, because you don't need to stream all that data to the cloud and then process it somewhere else, right? The data doesn't leave the device. So you have your device that's gathering all this data. Obviously, it's a camera, so it's gathering, you know, it's seeing the license plate, but it's doing something, you know, it's doing machine learning on the device, and then that license plate disappeared. Like, you throw it away, right? Like, it's not data that you're using. you just end up sending through JSON. You end up sending, I've seen a car. So you send a JSON file with I've seen a note to your Notecard, and that's it, right? Like so that's the beauty of like actually transferring some of that processing on the actual device, right? I think
it's such an important point. I mean, I think that's the whole reason we're here, really. Like, that's to be able to perform these inferences on these low-powered devices and not have to worry about, connectivity reliability necessarily, especially when you're talking about cellular and only connecting every few minutes. All the privacy and security, you don't want to be streaming. I mean, yeah, again, from a data perspective, you don't want to be streaming video necessarily to the cloud on these edge devices. You don't want to be sending images that could potentially contain PII or anything like that. And this just performing all that on the device and then sending out only tiny bits and pieces of information is just so critical.
And because you just mentioned the Notecard and connectivity, I thought I would bring this, community project, this question in. Just asking about, is the Notecard a way for devices to not have Wi-Fi, Bluetooth, cellular to get that kind of connectivity? So I know that we kind of skipped over that portion, but maybe you could just talk a little bit more about the Notecard and, some of the specs behind it, what's at its heart, the STM32, things like that, just to, kind of give some more detail around that piece of hardware.
Yeah, I mean, I can start, and Brandon, you can fill in all the details here. So the Notecard, I have one in front of me here, or with me, and I'll try and hold it up here. The Notecard itself is this tiny little cellular and GPS-enabled device. Let's see if my camera will focus on it. Maybe not. All right, well, you get the picture. It is what we call a device-to-cloud data pump. So it is a cellular module, and connectivity is globally available. I think it's 135 or some countries and counting. It does come prepaid, so we're very cost conscious as well. So it's a prepaid module for $49 US. That comes with 10 years of cellular service and 500 megabytes of data. And yes, you can top up the data as well. So there's no, we're really trying to make it, accessible to developers here. So there's no activation costs. There's no monthly cellular charges that you have to worry about. It's not like you're going to start getting a $10 a month fee the moment you buy the device.
Which is pretty, that's pretty common too, or, there's that kind of, again, that stigma around cellular. And I know, Brandon, you mentioned this before as well. I think that's why Blues Wireless in particular is really standing out in this space. Because
yeah, absolutely. As a developer myself, I mean, the thing that has always held me back from even prototyping with cellular is this idea of, well, I'm going to start a clock the second that I activate this device, and I'm going to start paying a monthly fee for data. So I really need to make sure I've got my real project before I start. And so what ends up happening is a lot of cellular devices just end up sitting on the shelf. I mean, I've got a number that still do, but I've loved with Blues this idea of, I like to tell people you can prototype without fear on cellular, because 10 years and 500 megs of data is actually quite compelling. And because the devices, I mean, it's a fungible module, but it's the same kind of thing that you can build it into an application. You can retrofit an existing board. That's the beauty of rolling with the M.2 connector technology that we have in there, is that you can design this. And as long as you have an existing solution or project that can speak serial or I2C, you can plug a Notecard in and just go nuts with it. But that idea of being able to easily drop it in and get going is really powerful, and it was very appealing for me when I first heard about it.
Yeah, and I think now Brandon said easy to drop in, and some of you may have seen the M2 Edge connector, and you're like, well, I can't easily just drop in a module with an M2 connector, and that's why I think Brandon mentioned this earlier. We do have companion development boards called note carriers that have that edge connector on there. In fact, I will show off. This is the Note Carrier Pi Hat, which is it has the 40 pin connector to your single board computer. Again, sorry, I'm not focusing very well there. But the Notecard does just fit in right there, and it's on that host board, which allows you to access everything via those headers. So. And we have, a variety.
I'll show one of the other ones. This is the Note Carrier, what we call the Note Carrier AF, which has an Adafruit Feather socket on it. Right now, there's a Nordic Adafruit Nordic Bluefruit that's plugged in here right now. So, because I'm working on a Bluetooth project. So, to that earlier question as well, is the beauty of this, because this is just a cellular module is that you can use it with a Bluetooth host MCU and go nuts with it. Use Bluetooth locally and cellular for backhaul. You could use it in LoRa deployments as your ultimate gateway across a local sensor network as well.
In terms of network too, so did I see a while ago, is it AT&T? Is that the network that?
So AT&T and all of their roaming partners is our current partnership. So that's where we get 135 plus countries. So there's permanent roaming agreements with all of those in all of those countries. Yeah.
And you had mentioned earlier, you mentioned the word retrofit. So that immediately, I thought that was a great segue into, why we brought you onto the show today to kind of discuss your project. So, without further ado, I think this is a perfect opportunity to kind of talk about how you, took your pool tank and kind of turned to analog, kind of digitized an analog, meter.
Yeah, no, this is, I love talking. This is a fun project to do. I've done a couple of things just tinkering with Edge Impulse over the course of the last year. I mentioned earlier that I have been a passionate about the tinyML space for a long, long time, back in early conversations with Pete and Daniel and others, that when I was at Particle, I was actually even doing some work getting TensorFlow Lite running on Particle's microcontrollers. And so I was just looking for an excuse to do something real with Edge Impulse. I went through the tutorials. You all have an amazing developer experience that we definitely talked a lot about internally while we were building out our own site in 2020. But when I had seen an article that a blog post that Pete Warden had put up on his blog talking about throwing the camera in front of an analog sensor as a way of adding ML to something without having to actually do anything to the project itself, without having to hack it. And I immediately thought of my pool tank. I have a pool at my house. My kids love that we have a pool. It is the source of endless grief for me because that's pool ownership is, great for the kids and kind of terrible for the parents. There's something that always goes wrong in a pool system. It is old technology by and large. And one of the things that I struggle with is there's a filter tank that's next to my pool system that has this little analog pressure gauge on the top of it. And if that pressure gauge is like under 10 PSI, there's something wrong with the system that I have to go in and clean things out, get leaves out of a basket, whatever might have you. If the pressure's low, it's bad. If the pressure's too high, I have to clean the filter because it's not able to actually turn the water over in the pool and keep it from looking green and nasty. And so it felt to me like a very nice way to take what Pete had been talking about in Edge Impulse and existing technologies. And my thesis was, if I just throw a camera in front of the dial and take a bunch of pictures at the various stages, I'm sure that I could run this and have it actually tell me if the pressure is too low or too high on a periodic basis. And so that's what I ended up doing. And I think what was cool is I had been thinking about it for a couple of months, and I think you all had just released the Linux SDK for Edge Impulse. And so I was like, well, I have no reason not to do it now. So I downloaded, installed it, went through the process, got the data acquisition job running on my Raspberry Pi. So what I ended up building, I guess I haven't talked about the hardware yet, is I ended up building a Raspberry Pi 4 sitting inside of a clear project box with a Pi camera pointed towards the dial. And then on top of that was a Pi Juice hat so that I could eventually run it off of solar once I collected all the data. And then a note card in the Pi hat. And this will come in a little bit later. But what I ended up doing was plugging it into mains power to start with, because I connected it to the Wi-Fi. I still had enough, distance from the house that I could connect to Wi-Fi for the purpose of data acquisition before I turned it off to conserve power when it was actually running. But ran the acquisition utility, ended up taking, I think, 200 some odd pictures of the dial in various gauges. And that was a bit of a hack to get the dial. This is one of the things about data acquisition that's tough. If you're monitoring a physical thing, is you have to sort of make the machine be in a bad state without it being in a bad state, right? And so I ended up taking a thin metal wire that didn't show up in the picture to force the dial into another spot, and we tried.
Did you end up breaking the device?
I didn't. Thankfully, I didn't. Yeah, but I had to sort of manipulate the dial a bit, and then I did get some real world pictures later. But I ran a few hundred pictures through it through the model. I went through the training. I mean, for those of you, if you're listening here, I'm assuming many of you have already used Edge Impulse, but if you haven't yet, the process of actually, as someone who has done TensorFlow work and TensorFlow Lite work in the past, I don't feel like I ever need to again, because
here's a testimonial. Hang on, we should have recorded this. Hang on, I gotta check this out.
It is so much fun to go through Edge Impulse Studio and go through the model training experience, from data acquisition to training and retraining, and all of that stuff is just it's just so great. So anyway, there's your you guys know where to send the check. You know where to send the check. Thank you, Artie.
It gives me goosebumps when you say that. Like my experience with Edge Impulse versus yeah.
It's seriously. But so I went through. I took about 200 pictures. I tried to capture I had the camera pretty tight on the dial. And actually, maybe I'll go ahead and share my screen, because I think it would be interesting. I'll share a bit of what my Edge Impulse Studio project looks like.
And while he does that, we also shared the link in the comments. If you want to check out the project yourself, as well as the inspiration behind it all, was the Pete Warden blog with his with the screen scraping and turning it into a dial. So that's now in the comments.
So I started with. And
Brandon,
so
you want to?
I took.
Brandon,
oh yeah, go ahead.
Sorry to interrupt you. No, I was just gonna say, do you want to make your window slightly narrower, because it's very wide right now? It looks it's very compressed.
Kind of tough on this.
It's fine. It's fine otherwise.
I bumped up the font. Hopefully, it looks a little bit.
That's okay. Yeah, we can see it now. Yeah.
So I started with 200 pictures. I went through classification, right? I created 4 labels: off, low, high, and now I can't remember the 4th label. But and normal. You get the idea. And went through 200 pictures, and a lot of them look like this, right? You can see, like, here's an example of what it looks like high. And there's a lot of these that are the same, but there are some that show up sort of in different light. Let me see if I can get to, there's what it looks like when it's off. You can see it's a little bit brighter outside. So I wanted to make sure I had a lot of different different images. And so I went through the process of it. It is just a simple classification model. And I went through and built this out. And I haven't been doing this right now, but I started with an accuracy of, I think, something along the lines of like 80% when I trained it. But when I went out and deployed it, I was getting like very, very, very bad results. So what I ended up doing over time, and you saw this in the data acquisition, it took me about 500 pictures to get it. But once I got it, I actually was able to get a model that was actually performing. It's probably closer to 95% when I actually run it on my end, when it's actually running on the device. But that's what I ended up, a very, very reliable model. And it was nice controlled environment just on the camera. And so what I ended up building out with the rest of that is, once I deployed it, it's running on solar power, viewing the tank. And then similar to what Rob showed earlier with the code, I am using Edge Impulse, using the runner to, once I get a picture from the Pi camera, perform an inference on it. And if it's high or low, I will post a note to the Notecard that then will ultimately go into Twilio and send me a text message to tell me that the tank is low or high. So I get that instant feedback of like, you need to go and clean your pool tank. And yeah, in the project, and Artie, you had mentioned this, I called this the ultimate retrofit, because we talk about retrofitting a lot with the Notecard, this ability to just drop this into an existing project or design around an existing solution, as long as it speaks serial. But this is a very similar thing. When I read Pete's blog, that was what I was inspired by, this idea of just throwing a camera in front of a tank gauge or in front of a power meter or something along those lines, and not having to do anything to the system itself, not having to line into the system and potentially break it, but just throw a camera on it and be able to actually get some insight off it. It was pretty cool.
And save some bucks, because you didn't have to go buy a smart dial or anything.
And save some bucks, exactly. Which there's a part of me that like never needs an excuse to go buy a smart anything, but it is nice to be able to like not have to mess with that system. So yeah,
because you strike me as the type of guy, you're probably like IoTifying your entire house, right?
I try
it all together.
My wife restrains me, so it's not too bad. Yeah.
But this. I mean, the whole point of like retrofitting stuff, I think is huge, right? Because it's not. We see it a lot when we talk to customers and partners that are trying to build stuff. It might not be like full retrofitting, like in this case, but it might be, look, I've got an M0 and I want to do object detection, right? Or I want to do whatever. Like they're always asking, because they've got products, right? And they're trying to like make these products do things that might not be, we might have not thought about, right? Like in a lot of cases, we might have like models that run on like more powerful processors. So we're always pushing down the boundaries of what models could do on smaller processors, or not smaller, more power efficient processors. Mm-hmm. And it's quite interesting because a lot of the times, like, you've got customers that are already out there with products, right? And you need to find a way to make it work for them. So I think, this concept of like adding a camera, adding another sensor on top of a product that you might have is actually super interesting, right? On top of like the fun project that you could do on your own. But as we were saying before, like, these are things that I think could be an inspiration for real projects in the industry, right? So super
especially
cool.
When you consider, like, everybody's talking about the billions of smart devices that there's going to be in the next few years, but what about all the legacy equipment that's out there, and bringing intelligence to all these things in the field? And this is a project that kind of exemplifies that. You know what I mean? Like, I feel like there's billions of other devices that could have intelligence without having to install some sort of new smart gadget. So I think that's also a pretty fascinating aspect of all of this.
Yeah. I think the phrase that Pete uses in his blog post is analog screen scraping, which I love that because it harkens back to my background as a web developer. But that's effectively it, right? You're bringing that screen scraping capability to the analog world, and that's really that's really powerful.
Super cool. Right, Rob, I think you're up again. You've got another project. This is the one that gained a lot of traction. I mean, there was Artie. I think you were telling me about how much traction I think you were following it on day one, and then day two you were like, oh my god, like, can't believe how much traction this is getting.
Yeah, I think we had to share it like 4 times because it kept getting 100 retweets. It was just one of those things that you just had to keep posting. It's like, all right, well, this is gold. But we mentioned it earlier on the show. This is kind of built out of a necessity. You started, you're walking. You could tell the backstory, but essentially, you were walking around the neighborhood. You saw these cars whizzing by. And it's like, what could I do as a citizen to try to kind of rectify this issue?
Right, classic story of man versus machine, right? Exactly. No, but yeah, I mean, just a quick backstory. The again, a kind of another pandemic inspired story for me to tell, where the lockdown hits and we are all of a sudden, all these activities we have going on are canceled. There's no sports practice to go to. There's no friend gatherings. And all of a sudden my family and I are kind of forced into the scenario of actually doing something together, meaningful and purposeful. So one of the things that we latched onto was, well, why don't we go for long walks in the neighborhood? So we ended up heading to we'd commonly go through a local cemetery because it's very quiet and peaceful. And then, I kind of noticed over time that, well, there's this road that we walk on a lot, and where, you're 3 feet away from these cars and the speed limit is 30 miles an hour and they are easily going 40, 45, 50. And it just kind of it just bothered me, as a helicopter parent. Of course, I want my kids to be safe all the time, every day of the week. So I was like, I'm so mad. I know they're going really fast. And then I was like, well, wait a minute. Why don't I actually prove this out? And it was, again, another one of these light bulb moments where it's like, wait, I actually could do this. And just like with the birding project, it was a matter of finding the right puzzle pieces to put together. And so for me, the first roadblock was finding, and no pun intended there, was finding a Doppler radar sensor that was relatively cost effective. The one I chose ended up being about $250 US, which is way more than I would normally like to include in a project, but it does a lot of amazing things. It's from Omni Presense, I believe is the name of the company. But again, it's a mature product, plenty of code samples out there. And otherwise, it was, I'm looking over at the solution because I have it wired up here on my wall here. The Pi camera module. I knew I needed to take pictures of this traffic as it was going by. And again, a dead obvious machine learning project. And in this case, I was like, well, why don't I use Edge Impulse? Because I've heard so many great things about it. And yeah, that's a great image to show because it shows the final deployment. And I have a limited version of that up on the wall right now. So this was the first project I'd actually ever used with Edge Impulse. And just to reiterate what Brandon was mentioning, the developer experience for creating, and this is again not a paid promotion, but the developer experience for creating these models from scratch was amazing. So what I did was I went out there and I take that back. I started with about 50 to 100 stock images of vehicles. And that was kind of my V1. And I loaded those all up into Edge Impulse and went through the process of labeling them. Is it a car? Is it a motorcycle? Is it a van? What have you? And after I was done with that process, I started doing some testing, some very limited testing, and I found it wasn't quite matching as I had hoped. And so my next phase was to actually take a bunch of photos on location. So I went out, sat down for a half hour, and one of the images you scrolled past, there was a cop car. There's actually a police vehicle that drove by that I got to take a picture of, which I thought was slightly ironic, and loaded up, I don't know how many, it was probably about 200 and 250 images of vehicles at the end of the day. And long story short, I mean, it was much like the birding project where I pieced all these puzzle pieces together and had a solution that was using an Edge Impulse model to infer what kind of vehicle was driving by. If it was a car, I kind of limited myself to I just wanted cars just to make it simple. If it was a car, grab the speed using this radar module and do some very simple calculations to determine whether or not it was speeding. One thing that was unique to this project is I used a feature of our NoteHub cloud service called environment variables. This allowed me to set the local speed limit remotely. So using our web-based UI, I could say, on my phone, I could just say, hey, I'm in a zone of has a 30 mile per hour speed limit. And the Notecard would go and grab that variable and download it, and then be able to determine with, obviously very simple math formula, whether or not somebody is speeding based on the data coming from that module. So then if I moved this to another location, I could set a new speed limit and it would just go out and grab that again. So at the end of the day, the only other tiny component I added was a 7-segment display, which would show me, again, another kind of pet peeve I have is putting a deployment out there and not really having any visual feedback as to whether or not it's actually working. So I used a 7-segment display to just show me radar data, so I knew it had a heartbeat, it was alive.
Kind of like the traps that you see out there nowadays, the big setups with the
right. Yeah, and so I had this all set up, and this is another kind of going back to my original point of like kind of garbage in, garbage out. It's very hard to test a lot of this stuff. We've kind of been hinting at this. And in fact, I did most of my testing right here, and there's not cars driving by. I didn't really have a good way of testing this on a limited basis. So what I ended up doing, and which I can demo as well, is I took a bunch of Matchbox cars and I stuck them in front of the camera. And this, the match wasn't great, but it was good enough to prove out that at least at a high level, this concept was going to work. All this to say, another disclaimer or qualifier I need to put out there is that the solution I built and that you read on Hackster, this is not a production-ready solution, right? There are a million more things I could and I would love to do to optimize that model, down to like setting my Raspberry Pi out there for a few hours and gathering 2,000 more images in real world scenario using the resolution and everything from the Pi camera. So again, kind of optimizing the model for the actual scenario it's going to be deployed in.
So I think the $1 million question that everybody was asking, wondering was, were you right? Were your assumptions of everybody going, at super speeds, was it accurate, or
I mean,
what were your findings?
Yeah, it was not surprising at all. Like my hypothesis was validated many times over. Again, there's an image I used UbiDots for my cloud dashboard. So the workflow, aside from the hardware, the workflow was gather up all this data over cellular, push it to NoteHub, which would then securely route that data to UbiDots as my cloud reporting dashboard. And so within, I don't even know how long I gathered data. It wasn't very long at all. I had determined that approximately 50% of cars were speeding, and I considered speeding to be going 5 miles over the speed limit, 5 miles per hour over the speed limit. And I think we topped out at somebody who's going like 24 miles per hour over the speed limit. Yeah, thanks for. If you scroll down a little bit, there's an actual image of that little one there. So just to show the location, the speed limit, the average recorded speed. So, again, no surprise at all to me. But yeah, I'd be happy to try and do a demo here. I've got my Raspberry Pi running if you want me to do a quick 2-minute demo.
Yeah, let's wrap things up with a real demo.
All right, let's see. Drum roll, please. Here, let me share my. I've got a.
And by the way, I see that you've got 16,000 views on this Hackster project. So well done.
Yeah, and what, a week and a half was it? Was it? Hasn't been that long.
Yeah, just a couple of weeks, I think.
Yeah.
Brandon's like, damn, I gotta build something. We gotta see if I get it.
Yeah. No, I love it. It's great. He has the title for our most popular Hackster project so far. So good.
Hopefully it's just the first of many though. So
that's right.
Right. So let's see if this works. Are y'all seeing my screen now?
I don't see it yet, but while we wait, we do have one question from Alvaro. Could the type of car be used to estimate emitted carbon dioxide, NOx, or other pollutants?
Ooh, that's a good question. I'm sure you could.
Cool.
It gets tricky. I mean, like a lot of these, to identify individual vehicles down to make and model, that's a tough problem to solve, just because of the similarities between models of cars. Mm-hmm. Not to say,
I guess one thing I was going to say on top of that is maybe what you could do is see if it's an SUV, a small car, a medium car. That could give you some sort of measurement. Maybe that's an interesting one.
Yeah, cool question.
Get an estimate, right? Yeah, cool question. Rob, you're up again?
Yeah. Are you seeing my screen? I'm sharing it, I think. Okay, good. So everyone's favorite Python IDE on my Raspberry Pi. I'm obviously not going to go through the code here, but what I am going to do is I'm going to run this script, and boy, I hope this works. And what it's going to do is initialize. Yeah, of course. It's going to. Sorry, I had the radar module plugged into the wrong port here. Let's try this again.
At least everybody can see that it's not a pre-recorded video.
Yeah, right.
That's right.
So what it's doing, it's initializing. There's a lot of steps to go through to initialize the radar sensing module. But what it's doing right now, it's using that Pi camera to run these inferences, and they are running. This is an edge impulse model. I'm getting inferences back in less than 400 milliseconds, which is pretty amazing. Oh, there it's. So now if you caught it in there, what is it bike and how confident 52? That means that it thinks it saw a bike when I was just briefly holding a car in front of it. So what I'm going to do now is try and see if I can get this to work. I'm going to hold my Matchbox car in front of it for a second. I'm glad that the bike one went through because we can actually still see the data flow. There it is. Okay, stop. Okay, I'm going to stop our flow here just so we can see what happened. So you'll see down here in the terminal window, so it identified a car, and it's 62% confident that it's a car, which makes sense because I'm literally holding a little Matchbox car in front of it. This just means that GPS is inactive because I am in my basement and I don't get a GPS signal. But at this point, what I have done is I have, using that edge impulse model, I've created this inference. I'm now sending this data up to notehub.io and relayed it onto UbiDots for display. And just to prove out that I'm not lying, I am going to share my NoteHub project. And
we're all waiting. Drum rolls.
No, drum roll, totally. Let's share. We need to share a tab. Share. All right.
There we go.
This is notehub.io. I have this project called SpeedTrap. This my device was last seen today. Well, this is my local time. So I've got an event here, and here it is. So this is the event that we sent on to UbiDots. And let's just look at the body so we can see the actual data we sent. 62% confidence. Well, they're not speeding because the speed that was gathered was 0 because nothing was actually moving in front of the device. But there's the lat long of the coordinates. the timestamp and all that. So it did actually work. So I'm kind of surprised, but no. How often do demos fail?
You know, as we're approaching the hour, you know, I think when you said the word demo, I think this is an opportune time to also plug our upcoming event, Edge Impulse Imagine. Alessandro, if you want to kind of take it away, I think, you know, we're hoping to have more proposals and more submissions over the next few days to host workshops of your own. Blues Wireless will hopefully be doing one as well. So if you want to, you know, if you were inspired by today, we definitely encourage you to submit a proposal over the next day or two, hopefully, or a few days, so we can nail it down.
Yeah, and just a few words on that. So it's an awesome event that we're doing. It's our first event that we're doing in September. It's at the end of September, 29th of September, 30th, and 1st of October. And the first day will be hybrid, so we'll be streaming from the Computer History Museum in Mountain View. And then 2 days will be fully virtual, and it will all be workshops for everyone to learn about Edge Impulse, but not only Edge Impulse, all the other amazing partners are working with us, and all the other great technologies like Blues Wireless, for example, so cellular connectivity. And you know, there'll be a chance to like deep dive into different technical topics throughout the 3 days. And yeah, as Artie said, feel free to share your ideas for projects or workshops, and check out the website, and you'll find submit a project at the end. So we're looking forward to all the project submissions. And I think after that, we wanted to do a plug again for you guys. So we want to share.
Yeah, if you were inspired by today, you know, these projects, it's like, oh man, I gotta create a project of my own using Blues Wireless. Again, 20% off one of their 2 starter kits using this link right here, bit.ly/pi- oh, sorry, that's your webinar. It's bit.ly/blues-omel, and you can get 20% off one of their 2 starter kits. And if you do want to learn a little bit more, yeah, take it away, Alessandro.
Yeah, exactly. No, I was just going to say, Rob, how are you?
Yeah, so we're hosting a webinar in about a month that is going to dive into both of the projects I just covered, actually. So we're going to do more of a deep dive into the birding project and the traffic project. So if you're curious at all, join, totally free. We're just going to have a fun, like 45 minutes or so covering these in a little more detail.
And Rob, do people need to have the hardware with them? Raspberry Pi, anything like that? Or
not at all. No, I mean,
no?
If they want to, that would be great. Yeah, use that discount code. But no, absolutely not. You can just follow along on the screen.
Awesome.
And Brendan, do you have any closing remarks? I know we kind of hogged the conversation towards Rob for the past few minutes. So do you have anything else
gosh,
you'd like to add?
They're awesome projects. No, I really appreciate you guys giving us a chance to come on and talk about what we're doing and to share how much we enjoy using Edge Impulse. And for the folks that are listening, please do check us out at blues.io, use the discount code, reach out to us directly on social. We are around and would love to hear what questions you have and hear about the projects you're building. So please be in touch.
And then once you do build a project, be sure to submit it to one of the community pages, the sites, whether it be Hackster, Hackaday, Element 14, whatever it may be.
Absolutely.
Yeah.
Awesome. Well, guys, it was a pleasure. It was really great to have you on. Thank you for joining us, and thank you to everyone watching. It's always good to have these chats. I enjoy it a lot. Artie, any closing remarks?
No, but we do have 1 registration for the webinar, so we're good to go.
Right. Thank you, David.
No, thank you,
Awesome.
everybody.
Thank you, guys.
Thank you.